In the previous video, we saw what is the principle behind counting, correct? Such a simple thing. Whenever we talk about counting, see, counting can be written as m into n. Remember, n has to follow m, correct? Let's do a quick visual representation as to what we can do here. Okay, now assume that you're in a running race. Okay, now in running race, there are only three places, correct? First, second, and third. All right. Now let's do a math wherein there are five people. Okay, so assume that there are five people. 1, 2, 3, 4, and 5. There are five people. But when it comes to the, for this thing, the race part, you have only three positions, correct? So the 1, 2, and 3. Okay, this is the first place, second place. This is the third place. There are only three places, and there are five people. So let's do the math here. Okay, now for the first place, all five of them are going to compete, correct? Make sense? So for the first place, all five of them are competing, and of the five, one of them is going to come to the first place, correct? For the second place, now how many of them are competing? Four, isn't it? Because the first place is already done. So there were five, the first place is done. Now we have four. So for the second place, we have four. For the third place, there are going to be three. Don't you think this is principle of counting? And here there are 2 points what you have to understand. Okay, now in the first case, the formula is the same. M into, the first case is M, principle of counting, followed by N, followed by P, some value P. Make sense? M followed by N followed by P. Now this is principle of counting without repetition. It is a very, very important thing to understand that this is without repetition. Okay, because see, a person once he gets first place in the running race, he can't get second place in the same running race, correct? I mean, it makes no sense. First person is first place. That's done. Isn't it? This is without repetition. Now, what if we do have repetition? As in, let's take another example and let's try to figure it out. Okay. Now, if you are trying to calculate, the counting with repetition, okay, let's talk about numbers, or let's talk about very simple things. Let's talk about arrangement of seats. Okay, arrangement of seats. Or you can also take an example wherein, you're trying to choose a dress or something. You're trying to choose a shirt, pant, and everything. All right. So for this again, let's say there are 1, 2, 3, 4. There are four people. So four people, what's going to happen here? Let's say they're trying to, arrange flowers in a bouquet. Okay, flowers in a bouquet. In the sense, there are four bouquets. So let's take four bouquets. 1, 2, 3, 4. Okay, this is flower 1, flower 2, flower 3, flower 4. We can take it that way. Or there are four people and there are four bouquets and they have to arrange the flowers. Alright. Now, in this case, repetition can happen, correct? Like in the sense, say the first person can put rose in all the four bouquets. Correct. Second person can put daisy in all four. In this case, what do you have? You have repetition, isn't it? So that means for the first place, okay, for the first box, whatever you see, there are going to be four places, isn't it? So that means you have four here. And in the next case, again you have four because it's repeating. Again four, again four. So now 4 into 4 into 4 into 4. Correct? Suppose if there were five places, assume that there are five, there is another one, fifth. Now again you will get 4, isn't it? See, 4 into 4 into 4. So there are 5 times. Now mathematically, this is nothing but 4 to the power of 5. Correct? So in general, you can say that m to the power of n. This is the number, or you can say total number. Total number, this is with repetition. Guys, it's a very, very important thing to understand. This is with repetition. Only when you have with repetition, the same number will repeat n number of times. But if you have, I see every time if the number is decreasing by 1, like, without repetition, then you just do m into n into p into q into whatever. Understood? Two things you have to understand in permutation combination. That is, first thing, if the quantities are decreasing, like, that race, see this example, when we took this example, the number of people are decreasing every time. So you just do m into n into p without any issue. Suppose if the number of people or number of things are repeating, it remains the same. Okay, then there is no decreasing in the value. The body, the things are getting replenished every time. Then you have to take this one, m to the power of n, where the total number, as in the number of things here, remains the same. Okay, this is about principle of counting. Now, in the next video, we'll solve couple of problems based on principle of counting. Okay, this could be based on the case where there is no repetition, and there are certain cases where it can be repetition. Okay, so you will see different types of problems. Then you guys will understand how and how to apply the formula and what kind of problems you guys are going to face. Okay, we'll start with the problems from the next video.